Okay, in this video I'm going to show you how to take the derivative of a more complicated exponential function than we've seen before, and also how to compute the slope of such a function at a particular point. So I'm going to compute two things. Really my final answer for this problem is f prime of 1. So this is the slope of the tangent line to f of x at x equals 1. But before I can get that, of course I need the derivative f prime at x. So once I have that, then I'll just substitute x equals 1 into that to get my final answer. So to compute the derivative of this function, e to the 4 minus 6x to the 4th times natural log of x to the 4th plus 7, I need the following differentiation rules. This one we've seen before, well, all of these we've seen before. If my function is the exponential of another function, so e raised to the g of x power, the derivative is this function itself again, e to the g of x. But then you multiply that by the derivative of only the exponent. So it's e to the g of x times g prime of x. Note that g prime of x is not including the exponent. So watch your font size, if you will, when you write down your answers. So we need that to differentiate this part. To differentiate this part, we have a derivative of, if our function is a natural log of some other function g, our derivative is g prime over g. And finally, this function is a product, so we're going to use a product rule. I'm refreshing your memory as to what the product rule is. So the derivative of g times h is h times derivative of g plus g times derivative of h. So in this problem, you can think of, for purpose of applying the product rule, this is g of x, and this is h of x. But then as we carry out the product rule and compute g prime and h prime, then we need to make use of these other rules right here. Okay. So applying the product rule, I'm going to have h of x, so natural log of x to the 4th plus 7, times the derivative of, and I'll only carry out differentiation one step at a time so you can see the process. So times derivative of that, which I'll do a little bit later, plus the exponential part, e to the 4 minus 6x to the 4th, times the derivative of h of x, so the logarithmic part. Okay. So now I've completed carrying out the product rule. Now to take these individual derivatives, I need to use the other rules that I've written down here. So I have natural log of x to the 4 plus 7, and then times the derivative of this. Well, the derivative of this is itself times the derivative of the exponent. Well, the derivative of, I'll just fill that in here, minus, well, really it's a whole exponent. I just left out the 4 because it's not going to contribute anything. The derivative of it is 0. And I take the derivative of that, so I have to remember to put the prime there, so we'll come back to it later. And then I have, moving on to this term, e to the 4 minus 6x to the 4th, times the derivative of a logarithmic function is 1 over the function you're taking the log of, x to the 4th plus 7, times the derivative of x to the 4th plus 7. So again, I'm putting a prime there. Okay, now I can take the derivatives of much simpler functions to finish this off. So I have natural log of x to the 4th plus 7 times e to the 4 minus 6x to the 4th times derivative of minus 6x to the 4th. I pulled down the exponent 4, so I have minus 6 times 4x cubed. And then over here I have e to the 4 minus 6x to the 4th times 1 over x to the 4th plus 7 times the derivative of x to the 4th plus 7. But that's just the derivative of x to the 4th. So that would be 4x cubed. Okay. So now I'm just going to simplify all of this. So I'm going to have to move this down. I'm running out of room. So natural log of x to the 4th plus 7 times e to the 4 minus 6x to the 4th times minus 24x cubed, and then for my second term I have e to the 4 minus 6x to the 4th times 4x cubed over x to the 4th better chalk here. 4x cubed over x to the 4th plus 7. And now the first part of the problem is complete. I've taken the derivative of the given function. It's kind of messy. But now I need the slope and x equals 1, and that is f prime of 1. So all I got to do now is substitute x equals 1 into this whole derivative. So natural log of 1 to the 4th plus 7, well, that's going to be natural log of 8. And then if I plug x equals 1 into here, 4 minus 6, so it's going to be e to the minus 2. And then times minus 24x cubed. Well, 1 cubed is 1, so I just have minus 24. And then for the upper part, I have e to the minus 2 again. And then I have 4 times 1 over 1 to the 4th plus 7, so that's 8. So now, if I simplify this, I have 1/2 e to the minus 2 from the second term, and then I have minus 24 e to the minus 2 times the natural log of 8. So that is the value of the derivative at x equals 1, so that's the slope of a tangent line to f of x at x equals 1.